In lesson 6.6, we're going to solve radical equations. So we'll start with a basic one, something you probably worked on in Algebra 1. So we need to eliminate the radical and expose the radicand. So to do that, I'm going to square both sides. So we end up with 5x minus 9 equals 1 times 1 is 1. And then we work to isolate the variable. We simply added 9 to both sides, divided both sides by 5, and ended up with x equals 2. And we can check our solution by subbing it back into the original equation. The next example has two things going on. We'll be working with a fractional exponent, and you can see that this left-hand side is a little bit more complicated. So there's just a couple extra steps. We'll begin by adding 1 to both sides. We end up with x plus 2 raised to the power of 3/4 equals 8. Now we're going to multiply both sides by 4/3 to eliminate the exponent. So the left-hand side became x plus 2. The right-hand side, the 8 raised to the power of 4/3 became a 16. We subtracted 2 from both sides. So our solution is x equals 14, and then again we can check by subbing it back in. But you might be saying, hey, wait a minute, how did you figure out that 8 raised to the power of 4/3 equals 16? So there are 3 different things you might have done. To determine the 16 from this, first you may have used your calculator, 8 caret, and then your parentheses around the 4/3. We know we can take the cube root of 8 to the 4th power, so that gives me 4 8s under the radical. So for every 3, I can take 1 out. And then this 8 is the same as 2 times 2 times 2, so I'm going to take out a 2. 8 times 2 is 16. The third example shows that you might have said 8 raised to the power of 1/3, and that is to the 4th power. So the cube root of 8 is 2, and then it's raised to the power of 4. 2 times 2 times 2 times 2 is 16. This next example is very similar to the last one we did. I added 9 to both sides, and then you can see I raised each side to the power of 3/2. So the left-hand side becomes x minus 4, and the right-hand side, because we have an even root, that means we'll have a plus or minus in our problem. So it's going to be x minus 4 equals 5 cubed, or x minus 4 equals negative 5 cubed. And then we're going to continue solving from there. When I continued working it out, we ended up getting x equals 129 or x equals negative 121. You could put it back in to see if both of them make true statements. But the key thing here is to note that when we have an even root, we're going to be dealing with a plus or minus in our problem. Now let's look at a problem with variables on both sides. And because we have variables on both sides, we'll be squaring both sides. We could be dealing with extraneous solutions. In an extraneous solution, you do the work correctly, but the answer might not actually be a true answer when you put it back into the equation. We're going to start by squaring both sides. So it's x plus 1 times x plus 1. So that comes out to x squared plus 2x plus 1, and then equals 7x plus 15. Now we want to set this equal to 0. So I'm going to move over my 7x and my 15 by subtracting 7x and 15 from both sides. So that will result in x squared minus 5x minus 14 equals 0. Now you might put it into your calculator to determine the x values. You can use any method you like, the quadratic formula. This one looks to be a good one for factoring. So we know the first term has to be x, and then we know, let's try 7 and 2, and the 7 has to be negative and the 2 has to be positive. So it multiplies to negative 14, but would negative 7 and 2 adds back up to the negative 5x. Now we apply our zero product property and solve for x. My solutions were x equals 7, x equals negative 2. I subbed the 7 back into the original equation. 8 does equal 8, so that checks, that's true. I subbed in the negative 2, and I ended up with negative 1, and it does not equal a positive 1, so the negative 2 is extraneous. We could have also used our calculator to figure this out. If you were to check using your calculator for the y equals, you would put in one side of the original equation, then you put in the other side of the original equation, graph it, hit second trace, scroll down to intersect, and basically hit enter 3 times. And your graph will look something like the one that I have up here, and it intersects at the 7, and it will also show that on the screen. In our last example, we have radicals on both sides. So normally we would try to move over the 3, but it's not going to help because we have a radical on the other side. So what we're going to do is square both sides. And that means we're going to have to FOIL the right-hand side. When I said the square root of 11 minus x times 11 minus x, it came out to the red 11 minus x. How that happens, we also know we could write it 11 minus x to the 1/2, 11 minus x to the 1/2, and we have to add our exponents, so it would be 11 minus x to the power of 1. So that's why the red 11 minus x looks as it does. And then now we're going to combine our like terms and put that on the right. Next, we want to keep the expression with the root on one side, so we will subtract 20 from both sides and add x to both sides. That gives us 2x minus 14 equals negative 6, and underneath the radical is still 11 minus x. Once again, because of the radical, we need to square both sides. We have 2 terms on the left, so that means we have to FOIL 2x minus 14 times 2x minus 14. So it would come out to 4x squared minus 56x plus 196. And then our other side, negative 6 times negative 6 is 36, and then the square root of 11 minus x, it eliminates the radical, so it's 11 minus x in parentheses. Now we need to distribute the 36. 396 minus 36x, and we have 4x squared minus 56x plus 196. At this stage, we're going to move all our terms to the left-hand side. We are going to factor, so we look at each term and we can see we can factor out a 4. So once we take out the 4, we're left with x squared minus 5x minus 50 equals 0. Now I can factor and get x plus 5, x minus 10 equals 0. I apply my zero product property, so I get x equals 10 and x equals negative 5. And now we can check our work. If you put the 10 back into the original equation, you're going to find out that it's extraneous and that our actual solution is x equals negative 5.